Let's read over this one. It says, the total number of public electric charging stations available for hybrid vehicles has increased exponentially. All right, now as soon as I see exponentially increasing, I'm thinking that. But sometimes people use that phrase, it's increasing exponentially, just to mean that it's going fast. But I think here, we're going to see this kind of a curve. All right, increased exponentially since 2005. The number of outlets at these alternative fueling stations, T years after 2005, can be approximated by this function right here. Now I'm going to write this. It's going to be A of T equals 228 parentheses 2.07 raised to the T. Now, T is the number of years after 2005, and T equals 0 then, well, that's exactly 2005. And they're even telling us that, right, where T equals 0 corresponds to 2005. So we're going to start everything at 0. 2005, that's going to be our 0. So actually, before we do any of these problems here, probably only need to do one, they're all the same. Can you see, if you put in 0 for T, here's what you get, right? We would get 228, 2.07 to the 0, but that's 228 times, now a number, non-zero number to the 0 power is a 1, which is 228. So this number right here, that 228, that's our start value. All right, so what's nice about exponential functions is that you can look at them and any number out here, not in the parentheses or not in here, not being raised to the power, any number out in front like this, any multiplier out in front, that's going to be your start value. So in 2005, we start with 228. Is it just, it's not in numbers or, I'm looking to see if it's in hundreds or thousands. The number of public electric charging available, I guess it's just 228 of them are available. All right, so just by looking at it, I can see how many I started with. Now, let's answer this question. We don't need to do them all. Just come out here to 2010. All right, so this will be part C. In 2010, T is equal to what? Well, 2005 is 0, so we got 6, 7, 8, 9, 10. Say 5 years. All right, so 5 years. So put that number in. We will get A of 5 is equal to 228 times 2.07 raised to the 5th. All right, calculator problem. And I'm getting that A of 5 is equal to 8254.75. You know what? These are charging stations. I can't have a fraction of a charging station. I'm just going to round this up. So I'm going to say in 2010, there were 8,255 charging stations. Number 7 tells us that the percentage of executives in a certain industry receiving cash signing bonuses is increasing. Now, it says the percentage of increase, I guess, is given by this function right here. I'm going to write that. B of T, I guess B for business, equals, or bonuses, 4.802, parentheses, 1.333 to the T. And what is T? Well, T is the number of years since 1996. All right, so T is the number of years since 1996. And what we want to do is find the percentage of executives receiving bonuses in 2000 and 2001. Let's just do one of them. How about if we go 2001? 2000. All right, so I'm going to say this. In the year 2000, T is equal to, well, how about if I take 2000 minus 1996, that's 4. All right, so T is equal to 4. So let's put that 4 back up in here, and we will get B of 4 years after 96. This is equal to 4.802, parentheses, 1.333, all to the 4th. Calculators again. All right, so I got that b of 4 is equal to 15 point, okay, 1, 6, 1, 5, so on. All right, but it's, find the percentage. Okay, does it say to round off to any place? No, it really doesn't. You know what, I'm just going to round off to 2 places. So I'll round off right here. So I'm going to say that the number is 15 point, right, find the percentage. Percentage is 15 point, say, 16 or 15 point, yeah, I guess just 15.16. Let's just go with that. Or if I just wanted to go to 1 decimal place, I'd round that up and go to 15.2. I don't know which one the book is expecting, but they're both about the same. Problem number 8 tells us that the number of concurrent users of a social networking site has increased dramatically since 2001. Now, by 2010, this social networking site could connect concurrently, at the same time, 70 million users online. Now, this function right here, I'm going to write that function. It is P of t equals 2.389 parentheses, quantity 1.481 raised to the t, where t is the number of years after 2001. So this function here, models the increase in millions of users. So what we want to do is to estimate the number of users of this site that could be online concurrently in 2002, 2006, and 2009, and round to the nearest million users. So let's make our estimations. Now, first of all, t, right, t is the number of years after 2001. So that means in 2001, t is equal to 0 because we're 0 years after 2001. In 2002, well, now we're 1 year after 2001. In 2003, t would be 2 years. 2004, well, now we're 3 years after 2001. In 2005, t is going to equal 4 years. And then in 2006, which is what we're looking for, we're now 5 years after 2001. So let's compute. So in 2002, with t equal to 1, here's what we're going to have. P of 1 is equal to 2.389 times the quantity 1.481 raised to the first power. My calculator says that P of 1 year after 2001, that is in the year 2002, I get 3.538109, probably keeps on going, but what we want to do is round to the nearest million, and all of these are in millions, so what we're dealing with this. 3.5 plus million. All right, round to the nearest million. Let's round that up to 4 million. So in 2002, we could expect 4 million concurrent users. Now in 2006, we're going to have t is equal to 5 because we're 5 years after 2001. So we'll get P of 5 is equal to 2.389 times the quantity 1.481 raised to the 5th. And I am getting that P of 5 is equal to 17.02 ... All right, so I'm going to say that this is about 17 million. I'm going to round to the nearest million. And I think I'll leave it there. For 2009, okay, in 2009, t is going to equal 8. All right, so you're just going to compute P of 8. And when I did this, I got 55.29, all right, 29. So I'm going to say this is about 55 million. Now we've got that the demand for lumber is increasing exponentially. All right, so as soon as I see that, I'm thinking this. As time goes by, here's the demand. It's increasing exponentially. I kind of see that graph in my head. Now, the amount of timber, N, all right, so N is going to be the number of billions of cubic feet of timber consumed T years after 1997. So T is the number of years after 1997. Can be approximated by this function here. N of T, the amount of timber, is equal to 65 times the quantity, 1.018 to the T. Now, in 1997, T is equal to 0 because we're 0 years after 1997. So the first question that we have is this. How much timber was consumed in 1998? Well, in 1998, we are 1 year after, all right, we are 1 year after 1997, so T equals 1. So we want to compute N of 1, and that's going to be 65 times 1.018 to the 1. And my calculator shows that N of 1 is equal to 66.17, but we're supposed to round to the nearest hundredth. All right. God damn it. Well, the nearest hundredth, this is the ones place right here. Right, that's the tens, the ones, the tenths, the hundredths, and it just stops at 7. So we already are to the nearest 100th. So I'm going to say this. In 1998, 66.17, now this is in billions of cubic feet of timber was consumed. Now, part B up here is asking how much timber was consumed in the year 2000. But in 2000, all right, now we're 3 years after 1997, right? 98, 99, 2000. So what we want is we want to compute N of 3, which is going to be 65 times the quantity 1.018 to the 3. And my calculator is giving me this. I'm getting 68.57355 and so on. But I want to round to the nearest hundredth. So here's the tenths. Okay, here's tenths, here's hundredths. Now that is a 3. That's below a 5. So I'm just going to drop those and go with this. In 2000, 68.57 billion, how about this, cubic feet of timber was consumed. All right, now this is not part of the problem, but what about this? In 1997 itself. In 1997, all right, T is equal to 0 because we're 0 years past 1997. But if I put T equals 0 in here, right, I'm going to look like this. 65, 1.018 to the 0. That's 65 times, now a number to the 0 power is 1, so I just get 65. So I get 65 billion. Now I can tell that by looking at this problem, at the function right here. What's the start value? So when T equals 0, that's where you start, and we're starting in 97. So I just get something to the 0, 65. So I can tell just by looking at it, that is the start value right there. The percentage of executives in some industry receiving cash signing bonuses is increasing. All right, so it's increasing, so I know it's going up, but it just says it's increasing. I don't know if it's going up linear or like this or like this. It just says it's going up. But now it says the percentage is given by this function right here. All right, so I'm going to write that function. It says B, I guess that's for bonus, signing bonus. B of t is equal to 4.801 quantity, 1.316 raised to the t. Now this function I recognize as exponential because the exponent, the variable is in the exponent. So because it's exponential, I can see right away from this function here a couple of things. First of all, it's exponential. So it has some start value, and then it goes up like this. Now that start value is right here. If you put, we start at times 0. If you put 0 in here, a number to the 0 power is 1. 4.801 times 1 is 4.801. So this number right here is at 4.801. So that says, when does everything start here? 1998. So this is in 1998. In 1998, or t is equal to 0, because t is the number of years since 1998. Okay, so I got a lot of information from that problem already. Now here's what we want to know. Find the percentage of executives receiving signing bonuses in 2004, 2005. Okay, so in 2004, t is equal to 0. T is equal to 6, and here's how I'm getting it. 2004 minus 1998, that's 6. All right, so let's put 6 into our function. So we will get b of 6 is equal to 4.801 times the quantity 1.316 to the 6th. Now my calculator says that b of 6 is equal to 24.9383, and it keeps on going, but we're supposed to round, according to the instructions, round to the nearest tenth. All right, so the nearest tenth. Well, here's the tens, here's the ones, here's the tenth. So I'm going to round to the nearest tenth. So this is a 3. Look to the right, that's a 3. That's below 5. So I'm just going to chop that off, truncate it, and I'm going to get 24.9. I'm going to say that in 2004, 24.9%, right, that's what it is, it's in percent of executives received signing bonuses. Now, in 2005, t is equal to 7. So let's compute a b of 7. So we are going to get, I'll put 7 into this function right here. So we will get 4.801 times 1.316 to the 7th. And I am getting b of 7 to be equal to 32.8188 and so on. And if I round to the nearest tenth, all right, here is the tenth. Look to the right, that's a 1, that's below 5, so just truncate this. So we're going to say 32.8%. Okay, so what do we say? In 2000, if I wrote the whole thing out, it would say in 2005, 32.8% of all of executives received a signing bonus. So look at that jump. All right, in 1998, here's what we have. 1998, what was the start value? The start value was 4.8%. Now, 6 years later, in 2004, that number has gone up to 24.9%. And in 2005, 1 year later, it's now gone up to 32.8%. Okay, big jumps. That's because we're going exponentially. So you can see down here, if you have increased by 1 year, it goes up this much. But if you're over here and increase by 1 year, it goes way up.